Hello again. We are back for example 3. We are going to be taking our ideas and our understandings about exponents and trying to apply them to a slightly different situation. Now I know back in 5th grade you worked with exponents for powers of 10, meaning that your base of your number was a 10, or you may have also worked where the exponent was a 10. But more often than not, you'll see a base of 10 with different exponents up top. So this table gives us a great illustration of how 10 to the 1 has a value of 10, 10 to the 2 has a value of 100, 10 to the 3rd has a value of 1,000, 10 to the 4th has a value of 10,000, and hopefully you start to see a pattern here. So when you look at this pattern, what do you notice about our exponent and the number of zeros in the value? I want you to think about that. What do you notice about the exponent and the number of zeros in the value? I want you to write your answer somewhere on this page. What do you notice about that connection? All right, that should be enough time. Hopefully, you are seeing that a power of 1 or an exponent of 1 has 1 zero, an exponent of 2, 2 zeros, exponent of 3, 3 zeros, and an exponent of 4, 4 zeros, exponent of 5, 5 zeros. So somewhere on your paper, you should have written, when we work with a base of 10, the number of zeros in my value match the exponent. So it's really easy to see that 10 to the 5th is 10 times 10 times 10 times 10 times 10 in expanded form, and its value in standard form is 100,000. So that's a really important understanding because it helps us evaluate this type of problem, where we are given an exponent, a base, and it's being multiplied by another value. So in this example, you can multiply by the decimal. You have to get this first, and then in a calculator I can type 1.9 times 100,000 to get 190,000. And then I can compare numbers if I wanted to, depending on what the question is asking me. But the big understanding here is that when you have a base of 10, the exponent matches the number of zeros in the value. And it's also a really great time, a little bonus piece of information. We know this is called our power, or it's written in our exponent form. This, the really stretched out form, we call that expanded. By the way, folks, it'd be a great idea to write this down. And over here, where we have our answer, once we've evaluated, because remember, answer and evaluate are synonyms, this is our standard form. So go ahead and take a look at the try. It says that Raphael calculated the FOIL as 1.8 times 10 to the 4th power units thick. Evaluate Raphael's expression. Remember, we have to start with 10 to the 4th, and then multiply whatever that is equal to by 1.8. I'm going to give you some time to work on that, and I'll be right back. We're back, ladies and gentlemen. So we have the expression 1.8 times 10 to the 4th. Now, I gave you that prompt before I left. We have to start with our exponents. That's a rule about math. When I have something, exponents is something that I solve before I work with multiplication. And we'll get into that when we talk about order of operations in just a couple of days. So I need to do this first. So I need to know what 10 to the 4th is equal to. Now, I could have looked at my table. I could have done 10 times 10 times 10 times 10 in my calculator. I could have typed in 10 to the 4th power in my calculator. Or I could have remembered that this 4 tells me that I need to have 4 zeros, and I could have just dropped my 1 into its original spot. So I have 10,000, and I'm multiplying that by 1.8. So you need to, if you haven't gotten this far, take a second to figure out what that answer is using your calculator, or maybe just your mind. Alright, didn't need too much time for that one, I hope. Hopefully you recognize that that is equal to 18,000 for Raphael's calculated answer for the thickness of the foil. Alright, we're going to get some practice now with these skills. Check in with the next video to see how you're doing.